Hi everybody, and thanks for attending this session. So yes, you may have noticed that I am not the person shown in your booklet. Obviously I'm far younger and better looking. So Conor Gallagher, who was due to present today, had to go off to the US on some urgent business, so I'm delivering the presentation on his behalf today. So what I'd like to do is just run through a little bit in terms of agenda around who CAD-IT are as a company. It's the first time we've exhibited here, so it's always good to give a bit of an introduction of who we are, what we do. I'd like to run through a little bit around some high-level business concepts around service lifecycle management, some elements of content around the Siemens Rail contract, and then we'll have a look at some of the authoring elements and some of the technical publications content. But generally, I want to keep things at as high a level as possible today, if possible. So my role within CAD-IT UK is that I'm one of the directors and founders of the company. So hopefully I'm well placed to talk about this stuff today. So as a business, we're part of now a bigger group of companies globally called the CAD-IT Group. And us as a UK company, we're focused around a number of elements of what we do. So we're a business partner with Siemens PLM, and generally Siemens are specialists in more in the CAD arena, the CAD analysis, data management, product lifecycle management arena. So they are not particularly well versed in technical content, the creation, management and delivery of technical content, and that's where we act as their business partner. So for 17 European countries, we act as their preferred partner in this area. And we really consult on service lifecycle management, which technical communications is a big key foundation of, product lifecycle management, and also the interaction of how you can take your engineering data and all this rich material you've created in a CAD environment and then reuse that or repurpose that downstream into technical publications content in a linked way. And again, we're a partner with some other companies, so Just Systems around the XMetal authoring toolset and Cortona 3D, which we'll come on to talk a little bit about. So we work across industry, really. A lot of this is with Siemens, but we work pretty much mainly at the moment in automotive, I suppose automotive aerospace and industrial and heavy equipment, but there are some other projects we do as well. Some of the companies that we're working with, either alone or with Siemens, Aston Martin are probably our biggest sole customer currently, and what we do for them is we actually create content. So we've got a team of about 15 people at Aston Martin who create technical publications content, everything from owner guides, parts catalogues. We actually create their workshop manual procedures and times as well, verify those. So anything technical publications related to Aston Martin, we create as an outsourced project. So not only can we speak from a position of understanding for our customers from actually content creation, but also from a solution set as well. So almost an end-to-end turnkey opportunity. So one of the things I wanted to talk about first is something you may or may not have heard of before, which is the service life cycle and effectively service life cycle management. At a high level, it doesn't really change anything for you if you're an author or an illustrator or somebody as a hands-on person creating tech pubs, but conceptually as a business process, it has quite a big impact. So what we've seen in the last 5 to 10 years is quite a big shift from manufacturing companies going from producing a product and a set of documentation and selling that at a profit. We've seen a lot of companies move away from that because it's not that profitable anymore. And a prime example of a company who've implemented service lifecycle management would be someone like Rolls-Royce Aerospace. So Rolls-Royce Aerospace now have power by the hour. So they used to sell you a jet engine at a profit, and that was pretty much the end of their engagement with you, apart from maybe selling you some spares on an ad hoc basis. Whereas what they've now worked out is that if they sell you a capability for a price over a period of the life of that product, let's say 20, 25 years as an engine, then what they're doing is they're selling you a contract, a capability. Rather than I need 2 engines to go on this aeroplane, what they're saying is I need to be able to fly this plane from this location to this location and shift X amount of passengers for 20 years. And they'll pay now on almost a subscription basis. So they're paying for a capability rather than buying a product. And what that means is if you're buying a capability for the likes of Rolls-Royce Aerospace is that every minute that your jet engine is working, it needs to be being monitored, it needs to be being looked at for faults, it needs to be being managed for services. Make sure that when it lands at a location where a service is required or some sort of remedial maintenance, that the parts and the people are already there to do that in the best possible way. And this is where service lifecycle management has a big cornerstone that's built on technical publications. And the technical publications element of that is that in these cases where companies are moving to this business model, they need to be able to create better quality content that's easier to understand, easier to use, quicker to create, and in, let's say, enhanced or more formats that have previously been acceptable. And that's quite a big shift in paradigm for technical publications in these sorts of companies. What does that really mean? Well, in terms of workflows and processes, it has quite a big impact. So I say it, and I don't want to hear the room go, but technical publications in the industries I've worked in previously have almost been a poor relation to the manufacturing and engineering process. They've almost been an afterthought. So where you tend to have an engineering timeline and, let's say, a final design and engineering freeze, we all know that just never happens. It creeps. And that's acceptable in that world. But what it doesn't mean is it doesn't mean that the launch of that project or that product going to market creeps with it. So what it effectively means is you're compressing the timeline within which you've got to create those technical publications, and you're kind of just expected to do that. So in a service lifecycle management orientated company, what it says is, and what the ethos is that in actual fact we need to be creating these things collaboratively with engineering. And there's a bigger, more inherent importance here on this documentation, because once our products are out in the field, if we're not servicing them correctly, if they're out of action, we're losing money and we're paying financial penalties on that. And that's an important element which is raising the status of technical publications and the aftermarket in general and technical documentation within this area. So in terms of goals, SLM aims to increase after-sales spares profitability, deliver configured information, and when we say configured information, that's actually product-specific configured. So in the example of, let's say, a car, is it right-hand drive, is it left-hand drive, which engine has it got in it, has it got this extra aftermarket feature, has it got this, which interior has it got, which headlights has it got, xenon, non-xenon. You're now looking at creating documentation that is product or VIN specific or serial number specific rather than just generic. And we're looking to optimize and evolve projects and products through this way of working. So effectively, once you've got this information out into the marketplace, you're measuring it, you're measuring the response to it, you're feeding back into the design process so that new iterations of the product are better, more robust. And you're effectively doing that normally over a time period. So in the case of Rolls-Royce, an engine might last 20 to 30 years. In the case of Siemens Rail, a train's got to last 30 years. And ultimately, you're looking to improve customer satisfaction. So when we look at common service goals, these are all things that are important in this model. So reduce the cost and time of production of the documentation. So 50%'s ambitious, and a lot of people are like, that's not possible. But there's a lot of situations where people are pumping in the required funding to make this happen, and we've seen some really great success stories. And actually, Siemens Rail is pretty much one of those that's coming along still. VIN-specific content, as I mentioned before, it's not good enough now in these contracts or these industries to expect to have, let's say, a paper-based manual that's 1,000 pages that covers every single derivative of the product. It's got to be specific to the product that you're actually standing next to or dealing with. You want to sell more spares, so again, parts cataloguing is important, doing that in new media and ways that are easier to access, and make sure that the parts accuracy in terms of ordering is there, and again, 3D is helping that. And this switch from 2D to 3D, it's not necessarily mandatory, but what we find is with 3D documentation, the uptake is much better. The percentage of right first time fix is much better, and generally the documentation is being provided in formats that people are now comfortable with. So things like iPhones, things like tablets, 3D PDF, whatever it might be, HTML data. But new formats that people can relate to without having to get out a book, which is costly to produce. And effectively driven by PLM or CAD effectively. So what we're saying is, what's the point in designing and engineering an amazing product in CAD and then parking that over here and then walking over here and starting to create a load of technical documentation in isolation. It doesn't make sense to do that in this day and age. So connectivity and driving technical publications from CAD and bill of material data is becoming something that's really, really important. And also as maintain management. So we're talking about managing a product at a component or a machine level rather than just on a general basis. So as a little bit of history of how this all came about and how service lifecycle management is a bit of a kind of growing buzzword. Obviously in the early 90s there was a big push on lean manufacturing, and that was where all manufacturing and product companies were spending their money to be able to manufacture as lean as the likes of Toyota and those sorts of companies. In the late 90s it was the focus and the attention turned to CAD tools. How can we design this better and quicker in a better CAD tool? And for the last 10 years, it's been around product data management and product lifecycle management. I need a solution whereby all my CAD data is stored, managed with all the specs of my product. So holistically managing your product end to end. And the maturity of those tool sets, those PLM tool sets over the last 10 years or so, has now got to the point where it's enabled us to take that data that's all stored concurrently in one location and reuse that in a TechPubs context. So what we're saying is now that the maturity of those tools have now allowed us to plug into that and leverage off the back of it. And what that's doing for us is it's now allowing tools really to develop and push technical publications more than they've been pushed in terms of process and tools for maybe 20 odd years. It's really pushing the forefront there. And it's important to understand that because that's really the basis of Siemens Rail's contract, which we'll come on to talk about in a minute. So effectively, Gartner did a study not so long ago saying that businesses that sell or service capital equipment, they're saying that margins can be improved by 20 to 60%, depending on your field service, operations and logistics. And all of that is really based around the technologies you're using to drive down the time it's taking you to create your technical content, driving up the quality of the content for its usage, and the availability. Right person, right place, right documentation, right tools. And all of those things come together through the technical publication stream to be able to really make some serious business impact. And one of my favourite old quotes, a business absolutely devoted to service will have only worry about profits. They'll be embarrassingly large. I don't know what year he said it, but it came from Henry Ford. It can't be wrong. So when we come on to talking about the Thameslink project, this was a real interesting project for us. So this was something that we got involved with through Siemens PLM, who again produce the kind of CAD infrastructure to Siemens Rail. So the government awarded this project to Siemens, and it's worth up to £2 billion, which is some pretty serious investments and pretty serious money. That contract is to supply between 1,000 and 1,200 train carriages of the new Siemens 700 series train, which is being developed in Krefeld in Germany. Effectively, that equates to 115 trains and 13.5 kilometres of train end to end, which is quite a serious amount of kit. The first train is due for delivery in 2015. I think it's being tested a lot at the moment in Krefeld in Germany, and the project is a 30-year life cycle. So again, it comes back to this service life cycle management scenario whereby the government aren't buying 115 trains. What they're buying is a capability, and that capability is on these specific lines and between these stations on these days, these dates, these times, over these years, I want you to be able to shift X amount of people from here to here, here to here, here to here. So they're buying a capability. It's irrelevant to them how many trains it takes for Siemens to do that, or what those trains cost. They're buying a capability. They're buying the ability to move people in vast quantities from A to B on time. And as a result of that, if Siemens don't do that, if their trains are late, if they're out of service, they then have financial penalties against that contract value. So again, you're seeing this SLM model being fully utilised, whereby it's actually advantageous for Siemens to really deliver on this because it's much more profitable for them, but it offers low risk to the government. So if they don't do a very good job, actually they're going to get paid a hell of a lot less money. So it works both ways. It's interesting for the customer, and it's more profitable actually for the OEM. So some of the content challenges that Siemens faced, which were some quite interesting ones, were the fact that they decided to go ahead and propose this contract. They won the contract, yet they'd never delivered any technical publications content in-house before. They'd always just outsourced it to a TechPubs house, paid an amount of money for an amount of deliverables. And when we actually spoke to them about that, they couldn't equate the two. They didn't really know what they were paying per deliverable, whether that was expensive, whether it wasn't expensive. So it goes to show that there's still a lot of craziness going on out there in the industry, and far too much money floating about for people to be worried about. So what they needed to do was they needed to build themselves an infrastructure, an in-house infrastructure to provide this content. They needed to build themselves an in-house team to deliver this content as well. And effectively, they had to deliver 800 initial procedures, thousands more after that, but 800 initial procedures for approval through a regulatory body. And bear in mind, they'd never done this before as well. They'd never prepared content for a regulatory body before that had to be approved and signed off before their product could be deemed safe to go into service. They had no idea about workflows and incorporating those workflows into what they were doing as a design and engineering company. And they also had to supply multi-format documentation to multiple entities. So the regulatory bodies, the train service provider, Network Southeast, and a couple of others, but also to kind of satisfy their own needs internally as well. So multiple types of documentation. In terms of deliverables, they've got to create an operations manual, so a driver manual, which is normally about 10,000 pages of a text-based book, a train crew manual, description manual, maintenance instructions for repair, repair procedures, and overhaul and refurbishment documentation. On top of that, they then had to create parts catalogues and also a servicing and cleaning manual. And they wanted to do that in multiple formats, so not just one format. So they wanted to do this or have the ability to do this in a PDF, in HTML, and in iOS or tablet format on the Apple device. So in actual fact, they wanted not certain documentation in one of these, but all of that documentation in all of these when they choose the format as and when. So there was a high level of complexity around what they actually had to create and the outputs they wanted to feed those with. So in terms of an architecture perspective, they were already using some of Siemens PLM's CAD software and data management tools, a tool called Teamcenter, which effectively manages your bill of materials, your CAD data, and does your general data management on quite a large scale. It can manage all your spec documents as well. So from that perspective, they were using Teamcenter to manage their CAD data. They had an SAP installation which was managing their manufacturing data as well. So there's quite a lot of complexity, and all of this was in Germany, and the project was being done in the UK, so added complexity. So effectively, what we did was we pushed them down the route of creating a service bomb. Most people in an engineering context are comfortable or have heard of an engineering bill of materials. Effectively, it's all the parts in the structure that are going to make your product. Sometimes you might have a manufacturing bill of materials, which is the exact bill of materials that is going to be used to manufacture the product. So there's varying degrees of bills of material. Service bill of material is growing in popularity because what we're saying with the service bill of material is by having that, we're breaking out what it actually the product is when it's designed, what the product is when it's manufactured, and actually how we're going to service this. I.e., I don't really, when I want to replace this wheel assembly, I don't just go and buy the wheel. I buy a wheel and hub kit. So it's kitting of parts, and it's bringing certain elements together in a specific bill of materials that will be used in the aftermarket. And again, you're going to author against that. So the service bill of materials was created and managed within the engineering data, so against the CAD data. So effectively, a structure was created and linked to the service bill of materials. So effectively what we're now saying is we've got our CAD data, which we've created our components with. We're now going to use that to drive our technical publications. So the source of that was our actual engineering data, the physical engineering data. We then moved into the area of graphics and topics management, and effectively what we did is we used the CAD data that was linked to our service bill of materials, sent that out into a session of a tool called Cortona 3D, and then we illustrated against that, which we'll come on to talk about a little bit later. And then it's saved back into Teamcenter. What we can then do is we can then divide all this information up by serial number against the service bill of materials, which means you can then author against that so that we can actually have VIN or serial number driven content rather than just generic content. And it's all in a single workflow, all within Teamcenter. So Teamcenter is managing your CAD data. We've linked the CAD data to our technical publications content, so when one changes, the other one will be notified. So when we come to look at this idea of engineering bill of materials, in an engineering bill of materials, effectively, and this is in the case of a car, you would buy in from a supplier, let's say a suspension unit, you'd buy in from a supplier an engine as a unit. So you wouldn't be looking at buying, if you're an OEM making cars, you wouldn't be looking at buying spark plugs, you'd be buying a fully complete engine. But effectively, that engine's broken down into subcomponents, and when you've got to service that in an aftermarket context, you're not going to swap out one engine for another unless it's required. You're going to swap out the smaller components. Same with the suspension. So what you're actually going to do is you're going to kit this in your S-BOM. So in your service BOM, you've now got a kit of componentry which is at a more granular level. So rather than buying a new engine to plop in, take the other one out, you're going to buy maybe an oil filter, an alternator, whatever it is. So you're going to, let's say, bring those down in a more granular sense and create a service bill of materials. So here you can see that they're at a more granular level, so your service bill of materials looks different to your engineering bill of materials. And that's really the basis for driving your technical publications. You're going to hang all of your technical publications on these hooks effectively throughout your product end to end. So everybody should be fairly familiar with this model of the product design life cycle. So, you know, it's pretty generic across industry. You design something, you test something, you build it, you deliver it, you support it. And effectively, each of these has a set of documentation normally that goes with it. So in this context, the process relationships are for test, you've got prototype documentation and processing. For build, you've got obviously manufacturing work instructions, how to put this together. When you're delivering it, you've got your owner documentation. In this case, it was your kind of train owner manual. And then supporting technical documentation. That could be parts catalogues or anything else required to do maintenance or service that actual product. Traditionally, this has been a problem, though, on a number of cases, which is in the industries I've worked in and a lot of our customers, what we see is that each one of these is owned by a different entity within the business. So what you find is that the manufacturing people go away and create their manufacturing work instructions, and that information, there's a lot of that core, probably 50, 60% of that information could be also used in the owner documentation or the repair maintenance documentation. However, if you ask anyone in those departments what the other one's doing, they have no idea, they don't know what tools they're using. Normally they're completely different tools, they're disparate, so there's no connectivity, and effectively you've pretty much got three departments doing a lot of the same work, massive amount of replicated work effort. So there's no real smart initiative behind reuse of data across these areas. And that's something with all of our customers, we really try and hammer home that, you know, you can really cut down the effort and the work replication here by implementing a solution that's common across these areas. And what we find in this old traditional way of doing things, very disparately sourced information between these departments, very costly author review cycles. This part's changed, well, where does that feature? Does that feature in my documentation, his documentation? Oh, now I've got to go and change that. Very, very long time lags with these things of change and then reissuing data. Often launch delays on a product when there's changes late minute or last minute. Effort duplication, as I mentioned. Limited output formats, and still we work with a lot of people who think they're on the cutting edge by creating a PDF document, which, you know, for certain industries that works absolutely fine and there's nothing wrong with that. But in some industries, there's the opportunity to go a lot further than that. So the particular tool that we introduced to Siemens Rail was a tool called Cortona 3D. And effectively, Cortona 3D is a tool where you can input a bill of materials, you can input CAD data, you can input any assets you might have previously, like previous images, previous text, and it will consume all that data, and it will allow you one environment for authoring, illustrating, creating text. So it's one tool that does everything. You can do it all together. There's no need for this chain of events, effectively. So within Cortona 3D, it's basically built up of 4 key areas, or it will do 4 things for you. It won't just do pretty pictures, it will actually create you an end product. So that end product will either be a manufacturing work instruction that could be used on a manufacturing line, it would either be a service and maintenance procedure or manual that could be used by a technician out in the field. Training procedures, so you can create training information to train technicians or people working on a manufacturing instruction line, or parts catalogues. So you can create any of these actual products, and they're an end item, there's something tangible that can be used afterwards. The interesting thing is that when we talk about this is that we're consuming CAD data to do this. We're working off of 3D. Now, our output can be 2D, it can be CGM image, it can be XML. We can output anything we want, pretty much. PDF, animations. So it's very flexible in what it outputs. But what people normally say at this point is, oh, but hold on. If we're using our CAD data and we're using this out in the field, we're exposing our IP. We're putting our actual intellectual property into this. Well, effectively what happens is when you take your CAD data and turn it into a session of Cortona, it rips out everything, every bit of physical properties. There's no edges, there's no real surfaces. It's just really a big bag of triangles. There's no size or scale on it, so it can't be reverse engineered. So it is a safe format, and it's an ISO standard format as well, so it's going to be around for some time. And effectively, that can be connected to the Teamcenter environment, which is where Siemens Rail are hosting and holding all their bills of materials and their CAD data. So it gives us the ability to output to HTML, to XML, images, CGM, PDF, iOS, anything you want. And effectively, it does that to a set of standards as well. So if you're using DITA, it's DITA-driven, so it can conform to DITA. It can conform to ATA, S1000D for an aerospace, and also SCORM, which is a certified training standard. So it meets a lot of standards, and it's all XML-driven effectively. And I'll come on to show you some content in a little while. But effectively, the authoring process when we're using this tool is fairly simple, which basically is take every bit of data you've got already and throw it at Cortona. And in the context of Siemens Rail, we connected it to their service BOM. So what we were saying is we'd take a line off the service BOM, we'd send it out to a session of Cortona. If there was any pre-existing information we needed, so maybe some existing text or existing graphics or images, we can import all those as well into the session. We'd author our content, so create whatever we wanted, whether it be 2D output, 3D output, both, and then we'd save that back to Teamcenter. And as an output, we could then either have 3D interactive, 2D paper, or parts catalog generated content. So it was a very flexible way for Siemens who hadn't done any internal authoring to be able to use one solution to do everything. In terms of the authoring workflow, it's very, very simple. You create a Cortona-based item in Teamcenter, you hang it on one of the hooks of your service BOM, you then, which is linking it to the CAD, you then send it out to a session of Cortona, create your content, save it back, preview, publish, done. Very, very simple workshop and workflow process. And one of the interesting things here is, and the key thing is that by doing this here, creating a Cortona item in Teamcenter and linking it to our service bill of materials, what happens is when the parts change as a result of, let's say, an upcycle or up revision in design or engineering change, it will come and tell you that. And it will say, this is now out of date, there's a new release. What do you want me to do? Do you want me to update this and go and modify all of your content automatically for you? Or do you want me to freeze that, up revision it, or up version to another published version and update it there? So it gives you the flexibility in an automated change control process, which is fairly fundamental. You're creating a link between the engineering CAD data and you're driving your technical publications with it effectively. And that's key to cutting down on replicated work effort. It's key to cutting down on the amount of time it takes to create content. And it's also key to cut down on the cost of creating content. So this is just a screenshot from inside the Cortona tool. So I've tried to lay out enough stuff here to be able to kind of talk through. So, excuse me, effectively, you've got your CAD data, which has been brought in this liquidized format almost. And off of that, you can drive 2D images on the fly. You can create and author and work with your XML content. You've also got a timeline that you can manipulate for your animated content. So you can drive animation, you can drive the XML-based text and 2D imaging to collate together in one output, let's say. And one of the key things around this is that if you are working with the 3D CAD data and you're clicking around on the screen, so you've got your CAD data and you say, actually, I want to be able to move this strut. So I click on this strut and hit remove. What it would do is every command in Cortona has got a simplified English string behind it. So what it would do is when I'm clicking around maneuvering this stuff on the screen, it's writing the text for me. Now I can go and manipulate and edit that afterwards, but it does give me that baseline text, which I could use or choose to modify. So it gives me that flexibility, but effectively it's writing the instructions for me off the basis of what I'm doing on the screen. So very, very intuitive. So what I'll do is, this is the bit where it always goes wrong and everyone fears. I'll switch to showing you some live content, hopefully, and some of the actual output from the project. So, first of all, this is, ooh, it's on my screen. It's not on your screen. Hold on a minute. Let me see if I can remedy that. And if by magic, there we go. So this is an example of some HTML output that was actually created by Siemens Rail. And so what this does is, this is all pre-formatted with your style sheets in Teamcenter, in the content management element of Teamcenter. So it tells you it's a storage module replacement. It gives you a load of their applicability codes, safety conditions, and a lot of other information that's useful. And this is only a really short example, but effectively, if I scroll down here, it then gives me the exact steps, the cautions and warnings that I've put into my style sheet. So it tells me what I've got to do as my procedure. However, what you'll notice is that by each one of these step elements, there's a little 3D icon. And also there's one, if I show you just here at the top. Now what that does is it allows me to view this in a 3D context. So this is the bit where it was do or die. So, okay, my screen real estate is not too good here because the way that it's changed my resolution. But what you can see is, if I scroll up, oh, I can't, there we go. It's showing me my animated content, and against the steps, it's highlighting on the left the step that it's actually working on at that particular time. And it will throw up any warnings and cautions it wants around that I've inserted. So what I'll do is I'll run that again just so you can get another view of that. Scroll up here. So this is what the technician would be using, either on a laptop, on or some form of other device, let's say. So it's giving you the instructions, there we go, and it's actually highlighting the instruction and showing you graphically what you're actually doing. So I'm pretty sure you'll agree that the actual accuracy of doing anything by using this method is fairly high. But also, not just that, if I'm a technician and I'm working in a complex, tight area, and I don't particularly have this view that I've got here, what I can do is, I can come in, oops, that's not so good, is it? There we go. I can manipulate this data and I can move it to my own viewpoint or a better viewpoint from where I want to view this from. I can then freeze that viewpoint if I wish and then carry on playing the animation from that viewpoint. So I've got control over the content. So I don't have to just settle for a static animation, which often might not be the view that I actually want to view this from or create or do my work instruction from. I can actually manipulate this data myself, either on my laptop or on an iPad. So it gives you the flexibility to really utilize the content to the best of its ability. So again here, my screen real estate's gone, sorry, normally this is 50-50. But again here, you can see I've got a 3D parts catalog. And again, I can manipulate this data accordingly to what I want to see. Or I can set up some predefined explosions, which will then explode my product for me. And this is great because what it then does is it stops you from misordering parts effectively. So I can come in here, I can select a part on the screen, it will highlight in my bill of materials line and on the product. I can identify as the right part, and if I want to, I can add in here a shopping cart function or a button that backports this through to my ERP system to make that purchase. So this is a key area of cutting down on the areas of failing to effectively deliver or order the right parts for the right job. So it's again enhancing efficiency. And then I've got a different assembly here, and this is to DITA. So I'll play this one through. I'll actually make this, I'll put it on double speed so you can see. But effectively, this is a maintenance procedure. And again, run through. You can see exactly what you're doing. You've got the text-based string on the left and the content that's highlighted against it on the right. If you want to, you can jump down to specific areas and it will just show you that particular piece of animation. So you can see here how this works. It's very intuitive to use. And you can serve this particular content over a web portal, a device. The flexibility is pretty much endless around this, but the important thing is the quality of the content and the output, the time that it costs, well, the time and cost that it takes to create, and that enhancement on efficiency of what we're actually doing here. So what I'll do is I'll just pause this, and I will attempt to show you some similar content on a different device. Now I'm really pushing the boundaries. So, he breathes easy. Right, so this is a diving rig, which is basically sits on the bottom of the sea. And again, this is just a procedure illustrated on the Apple device. I can have all my parts listed down the left-hand side, but effectively, again, you can see what's going on here. Very, very easy to understand. I've got it planned on double speed. You can kind of choose the speed you want to play it at. But also, again, I can pause this any given time, and I'll show you it, so this isn't an AVI. I can manipulate this data to my own point of view, or where I want to watch this from, if it's not the particular viewpoint, and I can continue playing the animation. So it gives you a really good level of content output, but also it's just as easy to output the same content to 3D PDF or to a 2D static document, which will automatically be built in the Cortona session. So all of this gets built at once effectively. You're building a session, you choose the output, and that's effectively the way that we're looking to push technical publications forward, driving it from CAD data. And by driving it from that CAD data, what we're actually saying is that if there's a change, we know about it, we can automatically update. We don't have to go through and search our CMS or be a brain wizard on where everything is in what documents. We can update very, very quickly and very efficiently and reissue the documentation issue very quickly as well, which is, again, another real key to being able to get things repaired out in the field quickly to the right documentation. Okay, I'll switch back briefly to my PowerPoint. So effectively, this is one of the real things of the benefits of what Siemens Rail were really looking for. So at the top here, you can see in a traditional authoring process, which is the way that it used to be done when Siemens outsourced this, they designed their product. They'd have a design freeze. Once that design freeze was in place, they'd give the data to whoever it was who was creating the content. They'd author against it. And like I was saying earlier, if that design release date gets pushed back, that product release date doesn't. So it just compresses. And you've got more to do in a compressed timescale, which makes things more difficult. What we're saying now is that by using collaborative tools and driving this from CAD and PLM, we can actually start our authoring here. We can start it anywhere back here we want effectively because we're driving it from CAD. We accept that when we're creating this authoring, there's going to be design changes still after we've created content, but it's more a matter of fact of the system will inform us, it will tell us, and we make an informed judgment of whether we want to automatically update to the newer version because they're linked. So it will go through in the session in Cortona, it will say, well, actually, this was the viewpoint I had before, these were the parts I had before, these are the new parts, I'll replicate those viewpoints for those. So it just does everything for you. So it really does cut down this authoring time and really takes off the pressure in these cycles whereby design drifts and drifts. And this is key to the whole process. And effectively, it's a bit of an arbitrary figure, 50% in terms of reducing the time, but That's kind of the benchmark we try and set with a lot of the customers that we work with, a 50% reduction in content creation time and cost in certain circumstances, depending. In terms of the process improvement, so what we typically see, and these aren't definitely correct to Siemens Rail as yet because the project hasn't finished, but effectively what we're saying is previously things were taking 2 years authoring process with a team of about 12 people. Now we can do that in around 6 months with a team of, well, I think in this case it's a team of 6. Over the cycle of the project it will be 6.5, but about 6 people. So you're really reducing down what you're doing, and it's basically by joining the dots, by using smarter tools plugged into your engineering data which you've already created, so you might as well leverage, and actually benefiting off the back of what your engineering community have done. In terms of the new process, we're saying 7 months, reduced cost of 50%, and the important thing again is content reuse across documents of around 45%. So once someone's gone and created the maintenance and repair manual, in actual fact, you can pretty much hand that straight over to training. There's an element in Cortona where you can build in multiple choice questions, and you can certify technicians online anywhere in the world with that content you've already created, just with some simple questions against it. And that'll certify them pass or fail, and you can plug in an email address of an HR department, etc. So to summarise really some of the things we've discussed today, really, Siemens have made a pretty successful transition going from paying a big check to someone else to do their content to bringing that in-house with their own infrastructure, their own systems, and a fairly small team of people. They've benefited from driving this, I can't hammer this home enough, but really driving this from the CAD assets and the bill of materials, so driving this content and creating an SBOM that's all interlinked, where you've got this automated change process. It's facilitated a collaborative working environment, obviously, because you're now working with the engineering data, and effectively, I think most people that we talk to about reduction in creation time of 50% and costs by 40 to 50%. Most are sceptical, but it's more than possible. It really is. So thank you very much for attending the session. If anyone's got any questions, please feel free to ask them. Alternately, I will be milling around for the rest of the day if anyone wants to have a chat about anything. And I've got plenty more flashy iPad content if anyone wants to see it. Thank you. Yeah, sure. That depends. It depends how you want to do that and in what context. But if you haven't got CAD parts, you can still bring paper-based content into Cortona and not work with 3D data. So you wouldn't benefit from the connectivity back to your engineering data, and you'd have to probably manage that change manually if it's not 3D data, but you can still certainly create all the content. You can bring in your old content, you can overwrite your XML, bring in images still into a session of Cortona and create your outputs. You're probably not going to be able to create a 3D animated output without CAD data, but you can still create PDF content, XML content, or whatever it might be, just without the animated content with it. So it's still a useful process to manage the same content. Any other questions? Yep. Yeah. Yeah, I mean, I guess the difference is, there's a lot of talk about common source databases. What we're really saying is, the key difference here is that rather than a common source database, all we're doing is creating technical publications off of 3D data. If you're going to use your 3D data, in this context that the gentleman just mentioned, you wouldn't. But where you're a company who's got engineering data and you're creating the output as well, all you're doing is making one drive the other, and which is really common sense, and it's not getting into too much of an in-depth discussion around technical publications, which is quite often people get into this get down in the weeds too early. And I think that driving your content from your engineering data, it just makes perfect sense. And if one changes, the other's got to change, and it's helpful if when this changes, this automatically tells you. So effectively, it's just a way of linking two things together, which is either a bill of materials or CAD engineering data. And that bill of materials doesn't have to be in a data management system. It could be an Excel bill of materials you can consume with Cortona against data. So effectively, all we're saying, I guess the real difference is all we're doing is saying we're driving this from CAD data, or we're driving this from assets you already have, rather than working in isolation, which is what we see so much and is just no need for it anymore. Well, engineering, designing, manufacture over here, technical publications over here. It just doesn't make sense not to have this being driven by this. And it's a simple concept, really.
I think we're going to have to wrap it there because we've half an hour gone over. It's lunchtime, and we'd like to get some lunch. So if you do have feedback, if you'd like to fill in SurveyMonkey, they should all have been sent to them. I'm sure they'll find all the details.
Can you send me 100 times?
Thank you very much.
Thanks. Thank you.